Question: a projectile is launched with an initial speed of 14.5 meters per second at an angle of 35 degrees above the horizontal. The object lands at the same height from which it was launched, and resistance is negligible. Determine A. The projectile's maximum height. B. The projectile's horizontal displacement when it hits the ground. C. How long the projectile takes to reach its maximum height. So this direction is the positive x direction. And this is just the initial velocity. And this angle is 35 degrees. Because the direction of the initial velocity is 35 degrees above the horizontal, then the initial velocity is 14.5 meters per second, and theta is 35 degrees. Then A, its maximum height. From the previous videos, we already know that its maximum height equals the initial velocity multiplied sin theta square divided by 2 multiplied acceleration. But this formula is only for such a situation that the object lands at the same height from which it was launched. So the height of its starting point has to be the same as the height of its landing point. Then we put values in this formula. This equals 14.5 multiplied sin 35 degrees square divided by 2 multiplied 9.8. And this equals 3.53 meters. Its maximum height is just this value. Then B, so its horizontal displacement. We have this formula. The horizontal displacement equals the initial velocity square multiplied sin 2 theta divided by acceleration g. This formula is also only for such a situation that the landing point is at the same height as its launching point. So we put values in this formula equals 14.5 square multiplied sin 2 theta. Theta is 35 degrees, 2 theta is 70 degrees, and divided by acceleration 9.8. And this equals 20.16 meters. So its horizontal displacement is this value. Then C, how long the projectile takes to reach its maximum height. We know its flying time. The total time interval for its flying equals 2 multiplied initial velocity multiplied sin theta divided by acceleration g. We should know that for such a situation that landing point is at the same height as its launching point. For such a situation, the projectile would take half of its flying time to reach its maximum height. So it should be the total time interval, the total flying time, divided by 2. And this equals the initial velocity multiplied sin theta divided by acceleration g. And this equals 14.5 multiplied sin 35 degrees divided by 9.8. And this equals 0.85 seconds. So its total flying time is 1.7 seconds, and it takes 0.85 seconds to reach its maximum height.